Hi guys, welcome to my channel Exploring Physics with Priyanka Gautam, and our today's topic is scalar and vector quantity. And in this video we're going to understand the meaning of these two terms and most importantly the difference between them. So let's start. First we have is a scalar quantity, and the meaning of scalar is defined as physical quantity that has only magnitude. Now, what is the meaning of magnitude? Magnitude is generally used for size and measures. Okay, so for example, if we have a ball here and the size of this ball can be measured by mass, okay, so we can take the mass as equal to 1 kg. Okay, so this 1 kg is the magnitude for this ball, and if we assume that this ball is at a stationary position, so it doesn't have any kind of direction, so this type of phenomenon is basically known as scalar quantity. Now we're going to understand the meaning of vector quantity, and it is defined as the any physical quantity that has both magnitude and as well as direction. So again we're going to take this ball. Now this ball will start moving in a particular direction. Okay, if this ball starts moving with certain velocity, we can say v. Now we have both magnitude and as well as direction for this ball, so this is now a vector quantity. Let's try to understand this meaning of scalar and vector quantity by taking different examples. So let's proceed with different examples of scalar and vector quantity. So as you can see here, first we have mass. Now let's try to understand the meaning of mass. Basically, for any size or measurement we have two different type of quantity. One is our weight, which is represented by W, and mass for small m. Now W is basically your weight of the body, and it is a vector quantity because weight is a gravitational force exerted on a body. Okay, which we can also say acceleration due to gravity by acceleration due to gravity, and the formula of weight is equal to mg. Okay, now here we have mass. Mass is a number of constituent particle present in your body. Okay, so mass is a constant quantity. Okay, it will remain same on any point, on any place, but our weight can vary from one place to another because this is due to your gravity. Okay, so your mass is a scalar quantity and weight is a vector quantity. I hope this point is clear to all of you. Again we have time. Okay, time is again a scalar quantity because it doesn't have any kind of direction, and you already know about the mass. Energy. Okay, energy is present in every body. Okay, but again we don't have any kind of direction when we talked about energy, so again energy is a scalar quantity. Same for the distance. Okay, if one person is moving, okay, so it covered some distance but direction is not given in that particular case, so distance is also your scalar quantity. Now the last one is speed. Speed is basically defined as distance by time. As you can see here, distance is a scalar quantity and time as well is a scalar quantity. That's why speed is also scalar quantity. Now let's try to understand the vector quantity. The first one we have is displacement. Now try to understand the meaning or difference between distance and displacement. For example, we have a body over here and this body will start moving in this direction. Okay, so this minimum distance covered by this body is basically we can represent by using straight line. Okay, but if this body move in a zigzag path, okay, and reached this point, so the zigzag path you can say is the largest distance, and the minimum distance covered by this object by reaching this point is given by straight line. So in displacement, first of all, this is the minimum distance covered by an object. Secondly, it has some direction. That's why displacement is a vector quantity. Now we'll have velocity. Velocity is again a scalar quantity, and the formula for velocity is equal to displacement by time. Okay, Now we know that displacement is a vector quantity, but time is a scalar quantity. We have one vector quantity, that's why velocity is a vector quantity. Now let's talk about the acceleration. The formula for acceleration is equal to a velocity divided by time. Again we have one quantity which is vector acceleration. Okay. Now force. The formula for force is equal to mass into acceleration, and mass is a scalar quantity but acceleration is a vector quantity, that's why force is also your scalar vector notation. So basically vector notation is used by this horizontal line over this arrow. Okay, any quantity having this kind of symbol on it is basically known as vector quantity. As we know that force is equal to mass into acceleration, okay, where mass is a scalar but acceleration is your vector quantity, that's why force is also vector quantity. But now to represent it we have to use notation for vector, and we're going to put this horizontal line over it and this arrow. So this is the sign for vector quantity. Again we have another term which is v. Okay, v for velocity here. So we know that velocity is a vector quantity because the formula for velocity is displacement by time. Again we have one term which is vector, that's why this velocity is also vector quantity, and this is the symbol we used for vector quantity. So let's try to understand how this vector notation can be used for different quantities. So vectors are represented by arrows whereby the length of the arrow is the magnitude. Okay, the length is basically used for magnitude and the arrow itself indicate the direction. So we have both the term. First, this horizontal line is basically used for magnitude and this arrow is for your direction. I hope this point is clear to all of you. So let's move. Now as you can see here we have different directions over here, and these arrows basically used to represent the different directions of vector quantity. Now we're going to talk about the properties of vectors. Okay, so let's try to understand the different properties of vector quantities one by one. So first we have two vectors are equal if they have same magnitude and same direction. Okay, so let's try to understand this. For example, we have two vectors quantity A and B. If magnitude of A and B and direction as well same, so we can say that A vector is equal to B vector. Okay, now the second one is a negative sign is a vector that has the opposite direction to the reference positive direction. Okay, for example, whenever you saw negative sign on a vector, it doesn't mean that the quantity is negative, it means your direction is opposite to your other quantity. For example, we assumed vector A is moving in this direction. Okay, and if second vector B is moving in opposite direction with same magnitude, then we can use negative sign on our B vector with respect to A. This is the meaning of this second property. Now come to the third one. When vectors are added, we need to take into account both their magnitude and direction. Okay, we have to consider both direction as well as magnitude while we adding the two vectors. Okay, so let's try to understand the fourth point. The equilibriant is the vector which has the same magnitude but opposite direction to the resultant vector. We can understand this point by again taking two vectors A and B, and now we are saying the magnitude is same but direction is opposite. So we can write it as A vector is equal to negative of V vector. Okay, this negative sign is basically for your direction purposes, not for your magnitude purposes. I hope these four properties are clear to all of you.